In this example, it says determine the intervals for which the function is increasing, decreasing, and constant. And we're given this picture of a function. Now the words increasing, decreasing, and constant are words that we use to describe the y values. The intervals that we write down, these are intervals of x. These will describe where the graph is increasing, decreasing, or constant. So when I work on a problem like this, the first thing I like to do is to trace the graph going from left to right. So I'm going to start as far left as I can go and trace the graph. And I'm paying attention to the y values. I want to describe the y values. Along this section, the y values are increasing. Then it switches and the y values are decreasing. And then the y values are increasing. So let's label what we saw when we traced. This group of x values, this group of y values are increasing. And this group of y values increasing. And this group of y values are decreasing. When we write down the intervals, we're going to write the x's. So I like to use my ruler. I'm going to hold it vertically so that my ruler is pointing to the x-axis. And I want to pay attention to this group of x's that we said is increasing. What is the first x in that group? And what is the last x in that group? We can see that this arrow is going on forever. So this group is going to start at negative infinity. And then it's going to stop right here. So the x's are going to go from negative infinity to this particular x value, negative 11. So this function is increasing from negative infinity to negative 11. Now, in the world of mathematics, there's a little bit of debate on whether we're going to use parentheses or brackets here. And it also depends on what type of interval you're looking for, if you're looking for open intervals or closed intervals. The author of our textbook has chosen open intervals, so we're going to use a parenthesis here. Then we have an interval of decreasing, which starts right here, and it continues till right here. So this group of x's is decreasing, and that goes from an x of negative 11 to an x of 11. And then we have one more group of increasing. It starts here and stops here. So we're going to add that to our increasing group. It goes from 11 to 18. Once again, using parentheses for open intervals. We don't have any intervals of constant. So this function is increasing from negative infinity to negative 11, decreasing from negative 11 to 11, and increasing from 11 to 18. on this question, we want to decide what number must be added to both sides of the equation to make the left side a perfect square trinomial, and then factor the left side. So in this example, we have the equation y squared minus 12y equals 4. Now, the directions in this problem are describing a process called completing the square. The left-hand side right now only has 2 terms. And what we want to do is add a third term to create a perfect square trinomial. Now, the way that you come up with that third term is by starting with the coefficient of that linear term. So you would start, and this is what I called in our lecture the magic number. We're going to start with that negative 12. And then we do a little calculation on it. We divide it by 2 and then square it. Negative 12 divided by 2 is negative 6, and negative 6 squared is 36. This is our magic number. This is the number that we want to add to both sides of the equation. We're going to add 36 to the left, and so that the equation stays balanced, we're going to add 36 to the right. Then on the left-hand side, you've now created this perfect square trinomial. And we can factor it, and it's going to factor in a special way. Y times y is y squared. 6 times 6 is 36. We need minuses to create the negative 2y in the middle. And you see that both of these factors are the same, so we can write it as a square. So y minus 6 times y minus 6 is y minus 6 squared. In this example, we want to determine whether the following equation represents y as a function of x. The equation we're working with is 7x minus 6y equals 42. So since we're talking about this equation and wondering if it is a function, I wanted to pull up the definition of a function from our notes. A function is a relation such that for each element in the domain, there is exactly one corresponding element in the range. So in order to decide whether this equation is a function or not, we need to see that there is exactly one y for every x. One way of getting started on making that decision is to rewrite the equation as y equals. So we're going to start off with 7x minus 6y equals 42 and try to solve for y. We're going to subtract 7x on both sides. That gives negative 6y equals negative 7x plus 42. We're going to divide both sides by negative 6. That gives y by itself on the left equals 76x minus 7. So now that I've written this as y equals, I can think more about this definition. I want to think, how many y values will I get exactly one y value for every x? Will I get more than one y value, or any y value at all? So if you're not sure, just by looking at the equation, you can test out a few values of x. Let's test out some easy values of x. if I choose x equal to 0, that's an easy one, and y is 7, 6 times 0 minus 7. 0 times 7, 6 is 0, and 0 minus 7 is negative 7. So you can see for this value of x, I have 1y, exactly 1y. Now what if I choose another value of x? I'll choose another easy one, 6. Then y is 7, 6 times 6 minus 7. Those 6's cancel out, and you get 7 minus 7, which is 0. So for this value of x, I got 1y, exactly 1y. So hopefully you're seeing a pattern here that if I choose a value of x, there's only one way to work out what y is. And so this equation is a function. Now I do have a couple of quick tricks or shortcuts to very quickly tell if something is not a function. So let's take a look. This is also from our notes. So when you're trying to decide if an equation is a function, you solve for y. Write the equation in y equals form. If you solve for y and you end up with a plus or minus symbol, that tells you that you're going to have 2 y's for every x, and it's not a function. If you don't have a plus or minus symbol, chances are your equation is a function. Then here are the shortcuts. If you have an even power on y, that's going to lead to the plus or minus symbol, and it's not a function. If you have an absolute value around y, that's going to lead to a plus or minus symbol, and it's not a function. But in this example, we have this linear equation, 7x minus 6y equals 42. And we found that every x leads to exactly 1y, and so this equation is a function. With this example, we're given this graph on the right-hand side, and the graph represents the function h of x. So the graph of h of x is shown. We want to find the function values h of 1, h of 3, and h of 4. So the hardest part of this question is just understanding the notation. So the notation h of 1 is the name of the function, h is the name, and h represents the y. And the number inside the parentheses represents the x. So this question is really asking, what is y when x is equal to 1? And we're going to get that answer from our picture. So we're looking for an ordered pair that has an x of 1. So I'm going to go on my x-axis right here to where x is 1, and I want to find that point on the graph. And you want to find the y value that goes with that, and that's 1. So because we have the ordered pair 1, 1 on the graph, we know that h of 1 equals 1. So let's try it with the next one. H of 3. We want to know what is y when x is 3. So we're going to go to where we have 3 on our x scale. We're going to go find our graph and then find our y value. So that gives us a y value of 5. So on our graph we have the ordered pair 3, 5, and we have h of 3 equaling 5. Then let's look at the last one, h of 4. So what is y when x is 4? So we go to our x scale, we find the 4, we go up to our graph, and we have our y value is 4. We have the ordered pair 4, 4, and h of 4 is 4. So in this example, we want to find the point-slope form of a line with the given slope which passes through the indicated point. So let's start with this point-slope form. Point-slope form is a way that we write linear equations. That form is y minus y1 equals m times x minus x1. The m stands for the slope of the line, and the ordered pair x1, y1 is a point on the line. So if we know those two pieces of information, the slope and the point, we're able to write the equation of that line. Now in this example, we're given that the equation will have a slope of 1/5, and the line will pass through the point -3, 2. So we are given exactly the information that's needed, the point and a slope of the line. So we're going to take that formula, y minus y1 equals m times x minus x1, and I'm going to substitute for the slope 1/5. I'll substitute in for x1 -3 and in for y1 2. This gives me the equation y minus 2 equals 1/5 times x minus -3. And the only thing that I would do to simplify this further is when you have a double negative like this. I would write this as y minus 2 equals 1/5 times x plus 3. So this is your equation of the line with slope of 1/5 passing through the point -3, 2, and that is in point slope form.
Thank you for checking out my videos. Have a great day.